Hello students, welcome back to Rauso's class. In the previous class we finished about ligands. Today we are going to discuss about very important point of this chapter, that is Valence bond theory. This topic can also be said like this. Generally people call VBT. The main aim of this topic is to study about structure, to study about hybridization hybridization of coordination compounds, as well as structure of coordination compounds. Okay, so here I will explain these points, so listen carefully. This is a very interesting topic. You must have listened to many people, but here we have a very special trick, and that trick I'll explain at the end of the topic or end of the video. First listen these points. So to know these things, we need to know we need to have basic idea of two concepts. One is coordination number. Coordination number is very important word in this one. So coordination number means what? It means if you can take example like FECN 6 times 3 minus. Now here what is the meaning of coordination number? Coordination number means here the ligand will donate electrons, will donate electrons to central metal. Each ligand will donate how many electrons, that we have to see. Cn is a which ligand? Unidentate ligand, which we studied in the previous video. So unidentate ligand means it will donate one pair. Totally we have got 6 cyanide, so which will donate 6 electron pairs. That is called as coordination number. So coordination number of iron is 6. Understood? Now another example like NiH2O 6 times 2 plus. NiH2O 6 times 2 plus. What is the coordination number of nickel? H2O is which type of ligand? Unidentate ligand. Unidentate ligand means what? It will donate 1 electron pair. So totally we have got 6 cyanide groups which will donate 6 electron pairs to the nickel atoms. Therefore coordination number is 6. Very simple. Another example, NiCO 4 times, cobalt 4 times. Here cobalt is a which type of ligand? Again unidentate ligand, which means it will donate 1 electron pair. Each cobalt will donate 1 electron pair. Totally we have got 4 cobalts. So sorry, not cobalt, it is carbon monoxide, sorry. So 4 carbon monoxide will donate 4 electron pairs to the nickel, which means the coordination number here it is a 4. So definition, what can you write? Coordination number means the number of electron pairs received by the central metal. Received by the central metal from ligands. Received by central metal from ligands. Yes, that number is called as coordination number. Now I'll give you some more examples like this one. CrOx thrice 3 minus. What is the coordination number of chromium? That is a question. So now tell me, what is the coordination number of chromium? OX means oxalate. Oxalate is a which type of ligand? Didentate ligand, correct. Didentate, which means it will donate 2 electron pairs. So each oxalate will give 2 electron pair, which means totally 3 oxalate ions. So therefore 6 electron pairs will come to the chromium. Therefore the coordination number of chromium is 6. Correct answer. Now last example. If you can give correct answer here, then I can say you understood this word. Now what is the oxidation number of cobalt? Sorry, not oxidation number, coordination number of cobalt in this one. So chlorine is a which type of ligand? Unidentate ligand, which means it will donate one pair. Totally there are two chlorine atoms, which means two electron pairs. And En is a which ligand? Didentate ligand. En is a didentate ligand. So each En will give two pairs. Two twos are four pairs. Here four pairs and here two pairs. Totally how many pairs are coming? Totally six pairs of electrons are coming. Therefore its coordination number is 6. That is the word coordination number. So first we should understand this word coordination number. Now second word which we need to know is, second basic concept we should know is electronic configuration. Electronic configuration of D block elements, especially 21 to 30. So that is also a necessary concept to go for VBT, Valence Bond Theory. Here 21 to 30 elements, 21, 22, 30 elements. First of all, you should know what are those elements. 26, 27, 28, 29 and 30. 21, it is a scandium. 22, it is a titanium. 23, it is a vanadium. 24, it is a chromium. 25, it is manganese. 26, it is iron. 27, cobalt. 28, nickel. 29, copper. And 30, it is zinc. How to remember it? So if you know it, there is no problem. If you don't know, but you should have technique. Technique is that science teachers very cruel. Science teacher very cruel. Manage fees. They manage fees. Cooperate. So cooperate nickel, copper, zinc. So this is the better way. Is if you don't know, then you can say this is a better one to understand. So science teacher very cruel, manage fees, cooperate. So they manage fees, so cooperate nickel, copper, zinc. Now electronic configuration. Electronic configuration argon. So 4s will come, then after 3d. But as per energy wise, electron first will go to 4s, then after 3d. But we write orbit wise. We write electrons orbit wise. Orbit wise means it is a fourth orbit, it is a third orbit. So 3d will write before, then after we will write 4s. Understand? So when you are filling the electrons, first you fill in a 4s, then 3d. I'll give you one example. Suppose scandium. Scandium number is 21. So electronic configuration, what can we write? Argon number is 18. After 4s to 3d1. 4s to 3d1. But we have to write orbit wise, which means we will write 3d before and 4s afterwards. Similarly, suppose iron number is 26. Here what I am writing, it is argon 3d. First I will write 3d1, 4s2. Similarly, iron 26. So argon 18, then after 4s2, it's a 20 and 3d6, 26. But how I'll write, this is the fourth orbit, it is a third orbit, so orbit will come further. So I will write down as argon 3d6, 4s2. Understood? Similarly, suppose example nickel. Nickel number is 28. Now you write electronic configuration, it is argon number 18, 4s2, 3d8. But what I should do? Orbit wise. So that's why argon 3d I'll write before, 3d8, 4s2. So this is the writing electronic configuration. So argon here 21, what will come? 3d1, 4s2. If you can see, there is a magic, 21, 2, 1. So now argon, it is a 22. So what will come? 3d2, 4s2. 22, 2, 2. It is a 23. What will come? Argon 3d3, 4s2. You can see the magic 23, 21, 20, 21, 22, 23. Chromium, you know, exceptional case because of half-filled electronic configuration. It will be 3D, 5, 4s, 1. It is an exception. So I'll put star mark here. Now manganese, it is argon 3d5 4s2 25 25 25 23 22 21 like that. Now iron, argon 3d6 4s2. Now cobalt, it is argon 3d7 4s2. Nickel, it is argon 3d8 4s2. Copper, it is a argon. It is again exceptional case because of full-filled electronic configuration, 3d10 4s1. And zinc, it is a 30, argon 3d10 4s2. Okay, so here also chromium and copper both are exceptions, so I'll put in box. Right, so these are the fundamentals that one should have to go for the next topic. The next topic is VBT. So if you want to go for VBT, we must know these two words, coordination number and electronic configuration. Now I'm going to VBT, Valence Bond Theory. Yes, VBT example number 1. Hybridization I am going to check. So example number 1, it is FeCN 6 times 4 minus. FeCN6 4 minus. So first of all, central atom. First central atom is iron. So find the oxidation number of central atom. Step 1. So step 1 I'll write. Step 1 is find the oxidation number of central atom. Central atom is iron. So X, Cn, what is the charge on Cn? Cn minus. So that means 6 into Cn charge is minus 1 is equal to whatever the charge present over there. It is a minus 4. So X minus 6 is equal to minus 4. X is equal to plus 2. That is step 1. Now step 2. Step 2, what I should do? Write the electronic configuration of iron. Electronic configuration. This is the long method I am telling you. At the end of the video I will tell you shortcut. Electronic configuration of iron. Iron number is 26. So its electronic configuration is argon. Its electronic configuration is argon 3d6 4s2. 3d6 4s2. But here we have 2 plus. So I want to find the electronic configuration of Fe2 plus. What is the meaning of Fe2 plus? I have to remove the 2 electrons from 4s. The 2 electrons I am removing. So its electronic configuration will be argon 3d6. Now step 3. Step 3 is observe the ligands. Observe the ligands. Which type of ligands are there? If ligands are strong ligands like Cn minus, En, Co and NH3, if the ligands are strong, then we will go against 2 Hund's rule. Against 2 Hund's rule. What is Hund's rule? That is pairing we have to do. One we give one electron. I'll explain you. And weak ligands except these remaining, then we have to follow Hund's rule, right? So like for example here it is a ligand is what? Cn minus. So since ligands are strong, so 3d6 electronic configuration can be written like this. Fe2 plus, it is argon 3d6. Generally 3D, D is having 5 orbitals, 5 orbitals. Normally, as per Hund's rule, we put one electron in each box, then pair up. But here, since ligands are strong, we have to go against Hund's rule, because these ligands will provide energy. These ligands will provide energy to go against Hund's rule. So against Hund's rule means from the beginning only we pair up the electrons. 2, then 4, then 6. Okay, the remaining will be empty. That is a step number 3. Now step number 4. Step number 4, it is fill the electrons coming from ligands. Fill the electrons which are coming from ligands. So here ligand is Cn. So how many electron pairs it will donate? 6 electron pairs are coming from ligand. 6 electron pairs are coming from ligands. So you have to fill those in Fe2+. That is argon 3D. So 3D, here already 6 electrons are there. These are of iron. These are iron electrons. Now 6 pairs are coming. First pair, second pair. Now you can ask me, sir, where I will put the remaining? The next orbit, it is a 4s. The next orbit is 4p. S is having 1 orbital, p is having 3 orbitals. So here 1, 2 pairs. It is a third pair. It is a fourth pair, fifth pair, sixth pair. The red pen is indicating electrons coming from ligands. Now check the hybridization. Now it is almost, answer is over. Step 5. Check hybridization and structure. Hybridization and structure. Here electrons are going to which orbital? D orbital. How many D orbital? D2 and 1 S orbital. And P, how many orbital? 1, 2, 3. So D2 sp3. So hybridization here is D2 sp3. So I'll write hybridization is D2 sp3. Then structure, whenever D2 sp3 structure is octahedral, alright, we have to remember it. And there is no paired electron. If electron is paired, then all electrons are paired, then it is a diamagnetic. So magnetic behavior, it is diamagnetic because all the electrons are paired up. Diamagnetic because as all electrons paired up. And here inner orbital, fourth shell is outer shell, third shell is inner shell. Inner shell electrons are used, therefore the type of compound is called as inner orbital complex. Inner orbital complex. And here spin, electrons are paired, so spin is decreased because this electron spin is half plus half, this electron spin is minus half. So as electrons are pairing, so spin value becomes plus half minus half cancel, plus half minus half cancel, plus half minus half cancel. So spin is very less, that's why it is called as low spin complex. This is called low spin complex. If you want, you can draw the structure, that is octahedral. Fe is surrounded by 6 Cn groups and they all are forming coordinate bond. They all are forming coordinate bond. So 6 Cn groups, and the charge on this is 4 minus. This is the process. So now see the steps. You have to remember the steps. First is write the oxidation number. Second step is electronic configuration. Third step is observe the ligands. and fourth step is fill the electrons coming from ligand, and fifth step is check the hybridization and structure. Right, now I'll give you some more examples so you will understand better. Now example number 2, example number 2, it is NiCl4 2 minus, NiCl4 2 minus. Yes, now in examination they ask write its hybridization and structure. Yes, you have to remember the steps. What is the step 1? Find the oxidation number. Find the oxidation number. So nickel we don't know, it is X. Chlorine charge is -1, so you have to remember the charge of chlorine minus, so totally 4 into charge is -1, and whatever the charge is there on the numerator, on the upside, it is -2. So X minus 4 is equal to -2, implies X is equal to +2. That is done, step 1. Now step 2. Step 2, what is that? Write the electronic configuration. Write the electronic configuration. That is a step 2. Yes, now write the electronic configuration here. Electronic configuration of nickel. Nickel atomic number is 28. Its electronic configuration is argon. Yes, argon 3d8 4s2, 28. So 28. You can see the technique. And here +2 charge is there, which means 2 electrons will be removed here. So Ni +2. So the charge, so it's going to be argon 3d8 4s0. Right, step 2 is over. Step 3, these are very easy things. Step 3, yes, observe the nature of ligands. Observe the nature of ligands. Nature of ligands. Here which type of ligand is there? Cl. Cl is a weak ligand or strong ligand? I have given strong ligand. What are the strong ligand? Cn minus, Co, En, NH. They are only strong ligands. So here this is a weak ligand. So since Cl minus is a weak ligand, so pairing should be done as per Hund's rule. So nickel 2 plus is equal to argon 3d8 4s0. 3d8. So electrons, how I have to fill? As per Hund's rule. What is Hund's rule? First fill 1 electron in each box. 1, 2, 3, 4, 5, 6, 7, 8. That is fill the ligands as per Hund's rule. Now step 4. Yes, almost we are at the end. Fill the electrons from ligands. Fill the electrons coming from ligands. Coming from ligands. Here chlorine is which ligand? Unidentate ligand. So which means 1 pair. Each chlorine will give 1 pair. Totally 4 electron pairs will come from ligands. So here Ni2 plus. So it is argon 3d8 4s0. So here the ligand electrons. First of all, blue pen. Blue pen means the nickel electron. 1, 2, 3, 4, 5, 6, 7, 8. Now the ligands electrons. So the ligand electrons, they will come to 4s 4p. They will not come here. Here it is an empty space, but still it will not come because they are coming in a pair. So they will directly go to empty box. First pair, second pair, third pair, and fourth pair, because 4 pairs are only coming, 4 electron pairs are coming, so they will come to this one. So now what is the hybridization here? Can you tell? What is the hybridization? 1 s orbital and 1, 2, 3 p orbital. So it is going to be sp3 hybridization. Now step 5. Yes, step 5. What is the hybridization here? Hybridization is sp3, and sp3 hybridization means structure. The structure will be tetrahedral, and if it is a tetrahedral, it's okay, fine. Now magnetic behavior, I said here all electrons are not paired. Last time it was paired, now it is not paired, therefore it is paramagnetic, because they have two unpaired electrons. You can see, that's why it is a paramagnetic. Type of complex, here which orbitals are used for hybridization? Only outer orbital, 4s and 4p are used. 3d is not used for hybridization. Only 4s and 4p are used for hybridization. Therefore, it is called as outer orbital complex. Outer orbital complex, or spin. Electrons are not paired against 2 hands rule. So spin is high. Therefore, it is also called as high spin complex. It is also called as high spin complex. Now, whenever there is a paramagnetic behavior, there will be spin magnetic moment. Spin magnetic moment formula, mu is equal to under root n into n plus 2. Bohr magneton, where n is number of unpaired electron. How many unpaired electrons are here? It is a 2. So under root 2 into 2 plus 2. So which is root 8. Root 8 means something 2.8, around 2.82 Bohr magneton. That is a spin magnetic moment. The spin magnetic moment, what is the formula? Under root n into n plus 2, where n is Bohr magneton. Right, understood? Yes, practice it well. Yes, now I am giving you some problems for practice. Let us see whether you are perfect or not. You will understand with these examples. So first example, NiCO 4 times. NiCO 4 times. Second example, FeCN6 3 minus. FeCN6 3 minus. Third example, it is CONH3 6 times 3 plus. And next example, it is CrNH3 6 times 3 plus. Okay, so you practice these questions, and if you have any doubt regarding this, you can mention me in the comment box. And if you like the video, hit on the like button, subscribe my channel, and share with your friends, and share your views with me even. Right? Continuation we'll see in the next class. Thank you guys. Thank you very much. Take care of yourselves.
Subscribe now and press the bell icon. Never miss an update. Subscribe now and press the bell icon.